Welcome to the next session, my dear friends. In the previous session, we were discussing about the design parameters of the septic tank. Now, how to design the septic tank? Now, we are going to discuss how to design the septic tank. So here, design of septic tank. So septic tank will have a settling zone and a sludge zone. Okay, the septic tank will have settling zone and sludge zone. If you look at the septic tank, inlet to the septic tank, outlet, there will be, so this is settling zone and this is sludge zone. So here we will provide a outlet for gases, whatever the gases that forms in this reaction. Okay, so likewise, so we will send this outflowing effluent into a soak pit kind of arrangement. Okay, so now, so here septic tank design means designing the settling zone and designing the sludge zone, designing the settling zone and designing the sludge zone. So let us see first settling zone of septic tank. So design of settling zone of septic tank. So let us take the detention time. Here generally the detention time of settling zone is approximately varies in between 12 to 36 hours or 24 to 38 hours. Detention time, generally it varies between, the detention time ranges from 12 to 36 hours. In some textbooks it was given like this. In some textbooks it was given 24 to 48 hours. Okay. So this is the detention time of the settling zone. Anyways, the detention time will be provided to you in the examination. Don't worry. So volume of the settling zone. Volume of settling zone is equal to, so here volume of the settling zone is equal to, here dry weather flow will come into the septic tank. Storm water will not enter into the septic tank. Dry weather flow will come into the septic tank. So whatever be the dry weather flow into detention time. So this is the volume of the settling zone, So volume of the settling zone is nothing but it should be in a rectangular pattern like this. So, okay. So if you look at the three-dimensional view, so there will be length, width and depth of the settling zone. So that means L, B, H is nothing but the volume is nothing but Q dry weather flow into detention time. Now if you assume the height of the settling zone, okay, if you assume the height of the settling zone, so what is the settling zone height? That is liquid depth. What is the depth of liquid you are designing? So if you take this, then you will get the surface area of the settling zone. Surface area of settling zone, that is L into B, which is equal to Q dry weather flow into dt by H, or else volume by the depth of liquid. Okay, volume by the depth of liquid, that is nothing but the surface area of the settling zone. So this is the design of settling zone. So design means what? Getting the dimensions. Getting the dimensions is nothing but design. So suitable length and width value we can assume. So we know the surface area. So we can assume the suitable length and suitable width for this settling zone. Now after design of settling zone, we will design the sludge zone. We will design the sludge zone. We will design the sludge zone. So sludge zone design, sludge zone of septic tank. Here, what is the sludge accumulation? Here, the volume of the sludge zone is nothing but, so how much sludge is coming per day. Okay, so it depends upon the rate of sludge accumulation. Rate of sludge accumulation means how much human excreta that will go into the septic tank. That is called rate of accumulation. So rate of sludge accumulation, rate of sludge accumulation. Generally we take this rate of sludge accumulation in the design parameter, that is 30 to 40 liter per person per year. 30 to 40 liter per person per year. Now, so what is the cleaning period? Now, if you want to find the volume of the sludge zone, if you want to find the volume of the sludge zone, so we need the desludging period. After how many months or how many years we are going to remove this sludge? That is desludging period. Desludging period. It also varies. It also varies with the size of the tank. It can be vary from 6 months to 3 years depending upon the size of the tank. So this is desludging period. If you multiply it with the desludging period, then you will get how many liters it can accommodate per year, per person. Now how many persons are using? So if you know the number of users, then we can find the volume of the sludge zone. So the volume of sludge zone V is equal to, see, rate of sludge accumulation, rate of sludge accumulation. So this is having a unit of liter per person per year. Now I am multiplying it with desludging period. Desludging period. So if I am multiplying it with desludging period, now year will go. Now liter per person it is there. If I multiply it with number of users, then I will get in liter. Then I will get the unit as liter. So that means that is the volume of the sludge zone. See, the surface area of settling zone and sludge zone both will be same. As this is a prismatic member, prismatic shape. The shape is uniform for settling and sludge. That is why whatever the surface area, whatever the settling zone surface area is present, the same will be the surface area for the sludge zone also. So that is why already we have calculated the surface area from the design of settling zone. We have surface area. So the depth of the sludge zone. Now we are designing the depth of sludge zone. The depth of the sludge zone is equal to, so volume of sludge zone by surface area. Surface area means L into B, which we have already found for the settling zone, okay. So likewise, generally we design the septic tank. septic tank. So there is another tank called Imhoff tank. So this is all about the septic tank. Generally whatever the effluent that go, I already told you, we will send it into the soak pit or we will send it into the dispersion trenches. Let us briefly know about what is meant by soak pit, what are the dimensions of the soak pit, and what is meant by dispersion trench, and what are the dimensions of the dispersion trench. After that we will discuss the Imhoff cone. So after completion of Imhoff cone, septic tank topic is over. We are going to discuss the oxidation pond. Okay, we are going to discuss the oxidation pond, the last secondary treatment device we are going to discuss. Soak pit and dispersion trench, both are simply pits only. Trench or pit, both are same. Okay. So one more point here. So before going into the soak pit, the total volume. So we have found the volume of the settling zone. We have found the volume of the sludge zone. So the total volume of the septic tank. So what is the total volume of septic tank? So let us write this also. Total volume of septic tank is equal to volume of settling zone plus volume of sludge zone. So volume of settling zone plus volume of the sludge zone. So what is the volume of the settling zone? So volume of septic tank is equal to volume of the settling zone is dry weather flow multiplied with the detention time of the settling tank, okay, plus rate of sludge accumulation into desludging period or simply cleaning period. We can also call it as cleaning period. By multiplied with number of users. So this is the formula for the volume, to find the total volume. So we have found volume of the septic tank separately for settling zone, separately for the sludge zone. So this is the total volume of the septic tank. Okay, this is the total volume of the septic tank. So now let us discuss about the soak pit. Pit means what? Depth will be more. Trench means length will be more. So if you are sending the effluent through a trench, then we call that as dispersing. We are dispersing the effluent through the trench. That is nothing but a dispersion trench. Okay, so we will dispose the effluent into a dispersion trench. Okay, soak pit means it is a depth wise it will be more. So soak pit generally it will be having a dimensions of 0.9 diameter. Okay, and it should be having a dia of 0.9 meter and depth should not be less than 1.0 meter. So depth should not be less than 1 meter below the invert, that means where the pipe is, effluent pipe is going. So from the bottom point of the pipe, it should be at a depth of at least 1 meter. The soak pit should be at least a depth of 1 meter should be present. And this depth, so after digging this pit, so all the depth that will be filled with brick bats, okay, broken brick bats, like material which is having adsorption capacity as well as porosity nature. That means whatever the effluent will go into the deep layers of the earth's crust. So likewise, generally the soak pit will be present. So this is like a simple schematic view of a soak pit. So from here, so we will be having some kind of so it will be left opened so that whatever the water that will go out into the earth's crust. So likewise, generally soak pit will be present. Similarly, there will be dispersion trench also. So this dispersion trench will have a length more than 30 meters generally. So it will be having a length around 30 meters or even more, depending upon the effluent BOD. Okay, depending upon the effluent BOD. So dispersion trenches. It will be having little less width. It will be having 0.5 to 1 meter deep and 0.3 to 1 meter wide. 1.0 meter depth, and width is equal to 0.3 to 0.3 to 1.0, depending upon the quantum of effluent. Okay, depending upon the quantum of effluent, and the length will be greater than 30 meters. So length will be greater than 30 meters. Sorry, should not be greater than 30 meters. So it should not be greater than 30 meters. So maximum length we keep for the dispersion trench is 30 meter only. If you want more dispersion, you will increase number of trenches. If this is a septic tank, so this is the effluent pipe. So from this effluent pipe, we will transport this into one dispersion trench. If this is not sufficient, then we will be having another dispersion trench like this. If this is also not sufficient, we will be having another dispersion trench like this. So we will distribute into number of dispersion trenches upon the requirement of the discharge. Okay, upon the discharge at the effluent. So but this length should not be greater than 30 meter, and we will keep at least a minimum spacing of 2 meter between two dispersion trenches. Okay, we need to keep at least a difference of 2 meters between the dispersion trenches. Okay, so likewise, generally we dispose of the effluent coming out of the septic tank. Now next is Imhoff tank. So this is all about the septic tank. So Imhoff tank is kind of a improvement we made to the septic tank, because in septic tank the settling zone, that means sedimentation tank and sludgeization tank, both are combinedly working. So in Imhoff tank, generally we separate them away. So there will be a separate sedimentation tank kept inside the septic tank. So we separated the sedimentation zone and we separated the sludge zone. So that is why, so whatever the effluent going out of the Imhoff tank will be having very less concentration of BOD. But whereas in septic tank, the effluent may also contain more BOD, because when the flow is more, when sullage water comes, so the flow will increases, dry weather flow increases. So this flow will take away the sludge which is undigested. So that is why generally the effluent may have more BOD when even sullage water is also combining in the septic tank. So and also number of users. Generally septic tank is effectively can be used up to number of users of 200 to 300. So septic tank can can be effectively used up to 200 to 300 users. If the number of users more than 300, then generally this effluent, the rate of flow increases, because of which the effluent may carry the sewage, the solid sludge along with it. So that is why Imhoff tank is preferred. It is preferred when the number of users are more than 300. So when the number of users are more than 300, we prefer the Imhoff tank. So Imhoff tank will look like this. So this is a schematic view of Imhoff tank. So if there is any inflow coming into the Imhoff tank, it will directly go into a sedimentation tank. So this is a sedimentation tank, and there will be another sedimentation tank like this. So below which, whatever the influent that is coming here, so that will be entering into the sedimentation tank, and there the sedimentation will happen. So there will be a small slot from which the sludge will come out from the sedimentation tank into the sludge digestion tank. From this small slot of the sedimentation tank, the sludge will come. This is sludge zone. This is sludge zone. This is sedimentation zone. So this is provided to desludging. So this gap is provided to desludging the sludge. Okay. So this is the effluent. So likewise, so here inside the septic tank, we are separating the sludge zone. We are separating the sedimentation zone. So that is nothing but Imhoff tank. Okay. So here designing of Imhoff tank and all are not necessary. Only the difference of Imhoff tank and the sludge septic tank needs to be understood clearly. In a Imhoff tank, we have two compartments. Upper compartment is for the sedimentation and lower compartment is for sludge digestion. Okay. So this is about Imhoff tank. So let us move ahead into the last secondary treatment, that is oxidation ponds. See, oxidation pond is an aerobic device. So oxidation ponds are aerobic devices which are used to remove the BOD, the organic matter, and whatever the byproducts that are generated out of the secondary treatment using oxidation pond, so they are very stable. They don't need further treatment, so they can be used as a manure also. So which are plant nutrients. Okay, so let us see oxidation pond. So oxidation pond, it will be having a depth of 0.5 meter maximum, because it is aerobic device, treatment process. So because of which, to have the air flow into it, generally the depth of the oxidation pond is restricted to 0.5 meter. Here the oxidation pond, it is like a shallow pond which we see in our vicinity. So it is such a pond only, which may be having a very high in length, very larger width, but so it is not pond for drinking water, it is a pond for decomposition of the sewage. So here how the decomposition takes place. It is eco-friendly decomposition system because in this the aerobic bacteria, so whatever the aerobic microorganism will feed on the organic matter and they will produce end products. Okay, so the microorganism converts the organic matter into CO2, NH3, and CO2, NH3, PO4, H2O. So these are the byproducts that will be coming during the decomposition of the organic matter. So the microorganism will convert the organic matter into these nutrients. These are plant nutrients, not for us, they are plant nutrients. So by taking these nutrients the plant will grow. So by taking these nutrients the algal matter, so algae matter will grow by photosynthesis. So during the photosynthesis it will take the carbon dioxide and it will exhaust O2, oxygen, which is needed for this aerobic microorganism. So the aerobic microorganism will take the oxygen which are being evolved by the algae, and whatever the byproducts that are being generated by this microorganism will be taken by the algae and microorganism. This is called symbiotic relationship. Okay, so algae, so during the photosynthesis it gives O2 to the aerobic microorganisms. So during the decomposition so they will be giving CO2 to the algae. So this relationship is called symbiotic relationship. So using this symbiotic relationship, generally the organic matter will get decomposed to the least possible degradation will be done in the oxidation ponds. And this degradation duration, so the duration of this degradation varies from place to place depending upon the temperature at that location. If you go to Jammu Kashmir, there an oxidation pond. If you go to the Madhya Pradesh, there an oxidation pond. The time taken by the oxidation pond with the same parameters in Jammu Kashmir, the time taken to decompose the organic matter of an oxidation pond in Madhya Pradesh will be different. The time taken in the Madhya Pradesh will be lesser, the time taken in the Jammu Kashmir will be more because the temperature. Here in Madhya Pradesh the temperature will be higher, it is nearer to the equator, whereas Jammu Kashmir is farther to the equator. So that is why, so depending upon the temperature also, the duration of the decomposition varies from place to place. So that is why the loading rate, organic loading rate, how much organic matter that we can load onto the pond varies from place to place. It was given in the Indian standards. So depending upon the latitude and longitude, so they have given the organic loading rate that is to be given to the water oxidation pond there. So by looking at the organic loading rate and depth, already I have told you the maximum depth to maintain aeration, to maintain aerobic condition, aerobic condition. So the depth of pond should be restricted to a maximum value of 5 meter only, sorry, 0.5 meter. So here the depth is restricted already to ensure aerobic nature. So only thing is the surface area. To accommodate the organic loading rate, you can play with the surface area, and also the length of the oxidation pond should not be more than 750 meter. So length of the oxidation pond should not be more than 750 meter. So if you are getting more organic loading, then you need to use another pond, but we are not supposed to increase the pond length as needed. Okay. So likewise, generally we design the oxidation pond. So what is the organic loading rate? So how the organic loading rate will be given in the code as per the latitudes? Let us see that. See, the efficiency of the oxidation pond depends upon how much time you are leaving the organic matter inside the oxidation pond. If you are leaving for more time, then the degree of removal will be very high, up to an extent of 95 to 99% we can remove the BOD. If you give sufficient time, as well as if you give sufficient aeration. So aerobicness is also needed, otherwise we cannot achieve the desired degree of removal. Okay. So organic loading rate, it decides everything. So this is the very important parameter of an oxidation pond. This is a very important parameter of oxidation pond. For example, latitude in India, so if you take the latitude, these are called northings. Okay, latitude and versus organic loading rate. The organic loading rate will be given as kg per hectare per day. Kg per hectare per day. So this is nothing but organic loading rate is nothing but BOD loading rate. It is nothing but BOD loading rate. If you take the latitude 36 north latitude, then the organic loading rate is 150. So if you are moving down, if you are moving 32 to the 32, that means you are moving down, means you are moving towards equator, because we are in northern hemisphere. So when you are moving down, means you are moving nearer to the equator. So 175. Similarly, there will be 8 degree latitude likewise, because India is in between 80 degree latitude Andaman Nicobar, 36 latitude Jammu Kashmir. Okay, so this is the latitude limit of India. So it starts at 36 ends at 8 degree latitude. So 80 degree means very nearer to the equator. So here the organic loading rate will be going to an extent of 325 kg per hectare per day. So likewise, if you are moving from the Jammu Kashmir to Tamil Nadu, Kanyakumari, or anywhere, Andaman Nicobar, all those locations. So this is how the organic loading rate varies in the India. So that value will be given to you anyways in the examinations. Don't worry. Okay. So generally L by B. So by looking at the organic loading rate, we can design the oxidation pond. So this is the organic loading rate already given for us. Okay. So how many days we are giving? So this is the kg per hectare per day. Okay. Now how many days you are giving to the tank for the detention time, for the decomposition process to complete, for the decomposition process to get complete. Okay, depending on that, we can design the oxidation pond. So, surface area. So, the surface area of oxidation pond So knowing the surface area of the oxidation pond is nothing but the design of surface area, design of oxidation pond. So now Q is so let us assume that Qi is the influent coming into the oxidation pond. Qi is the influent coming into the oxidation pond, and Yi is the BOD that is coming into the oxidation pond. Qi is the influent that is coming into the oxidation pond, and Yi is the BOD that is coming into the plant. So this is the organic loading. It is not organic loading rate, this is organic loading or BOD loading in kg per day. BOD loading in kg per day. If you know this, so this is numerator, Qi Yi is numerator, its unit is kg per day. And if you know the organic loading rate, kg per hectare per day. So that means, so by dividing these two, you will get the surface area in hectares. Surface area you will get it in hectares. So this is nothing but the design, because depth wise we have already restricted the depth. We have already restricted the depth to 0.5 meter. So only design of an oxidation pond is nothing but fixing the surface area. Fixing the surface area. That is nothing but the design of the oxidation pond. And this BOD loading rate, if you observe the organic loading rate versus latitude. So the organic loading rate is inversely proportional to the latitude. So when the latitude is increasing, organic load is decreasing. Both are inversely proportional to each other. If you want to find the detention time for a particular organic matter, here there is an empirical formula by which we can find the detention time of the oxidation pond. So detention time of the oxidation pond, T is equal to detention time of oxidation pond, T is equal to 1 by K ln Yi by Ye, Yi by Ye. So what is Yi? We all know this. Influent BOD. Influent BOD. Ye is effluent BOD. Effluent BOD. And K is pond constant or BOD rate constant, whatever it may be, degradation constant. Okay, so this is pond rate constant. This is pond rate constant. Okay, so by this way we can design by looking at the organic loading rate and by looking at the organic loading that is coming. So that is, organic loading will come from the sewage. Organic loading rate will come from the latitude where this pond is existing. If you know these two, we can decide the surface area of the oxidation pond, and also the detention time can be determined depending upon how much effluent BOD you are needing. So if you need more effluent BOD, you can reduce the detention time. If you want less effluent BOD, you need to increase the detention time. Generally it varies. This detention time of the oxidation pond, it ranges between 2 to 6 months. It ranges between 2 to 6 months. Okay, so depending upon what is your BOD removal requirement. Sometimes, so we are all talking, so far we are talking about the aerobic treatment process in oxidation pond. There will be anaerobic nature that will present in the oxidation pond also. So when we are treating the industrial water, so these industries generally they will construct a anaerobic oxidation pond inside the industries only, generally having a depth of 2.5 to 3 meters. If you look at the oxidation pond where the depth of the tank is more than 2 meters or 2.5 meter, there the sunlight can only penetrate up to smaller depth. Okay, so if the oxidation pond depth is around 2.5 to 3 meters, in those kind of ponds, generally in those kinds of ponds where the depth is very high, so in the top portion where the sunlight can penetrate, so that will be under aerobic condition. So below this there will be facultative. So there will be facultative condition. The facultative condition will arise here. So that means the bacteria or microorganism which can sustain both in aerobic environment and anaerobic environment, those kind of bacteria will present. Okay. So here anaerobic. Here anaerobic bacteria will present. So at the bottom of the tank anaerobic conditions will prevail. At the medium portion of the tank facultative condition will prevail. At the top of the tank it will be under aerobic condition. Now when it is happening in anaerobic condition, so it will evolve some kind of gases, but these gases cannot leave the aerobic layer. They will be trapped inside and they will be used by the aerobic bacteria as their energy sources. So this CH4 methane which is evolved in this layer, this will be utilized in the top two layers, so that the degree of removal will be more, the effectiveness will be more, and the sludge which is being generated will be less. So that is generally anaerobic treatment process in the oxidation pond is also possible. And one more important point here is, before sending the sewage or any sludge into the oxidation pond, primary treatment is necessary, is mandatory. Why it is mandatory? Why we need to treat the water, sewage water in primary sedimentation tank before sending into oxidation pond? So the sewage which is sent into oxidation pond must be treated in primary sedimentation tank, because if the turbidity is more, because if the turbidity is more, then it will not allow the sunlight and airflow to the bottom layer of oxidation pond. So the oxidation is not possible at the bottom layer. So that is why, in order to keep the system under aerobic condition, so less amount of turbidity is necessary. So that is why whenever we send the sewage into the primary sedimentation tank, into oxidation pond, pre-treatment in the primary sedimentation tank is necessary. This is the first point. Next point is, because here everything is dependent on algae growth, so the effluent cannot be directly sent into river water, because the effluent from the oxidation pond will contain more amount of algae. Okay, so the effluent in the oxidation pond will contain more amount of algae. The effluent from the oxidation pond cannot be disposed into river water, because it contains more amount of algae. So to control algae, we add sodium nitrate, NaNO3. Generally we add copper sulfate to promote the algae growth. To kill the algae, we add sodium nitrate. Okay, very, very important. To promote the algae growth, copper sulfate is needed. To control the algae growth, sodium nitrate is needed. So we add sodium nitrate, we reduce the algae, we control the algae, and then we will send that water effluent into the desired locations where it is permissible. Okay, so this is all about the oxidation pond. Now we have completed all the processes which are important for the gate examination. There is a last one, that is lagoons. Lagoons are nothing but they are also ponds only, but lagoons may not be getting proper aeration. Okay, so we keep all the sludge into a kind of pond, we leave it. It may be aerated lagoon or it may be non-aerated lagoon. So after some time, whatever the organic matter present inside this lagoon will convert into manure. Naturally it will convert into manure, so that will be used, okay, for the plant growth. Those are nothing but lagoons. Okay, those are nothing but lagoons. So this is all about the secondary treatment or the simply treatment of sewage concept. Now in the next session we are going to solve the previous gate examination questions, and we will learn any new concepts. If it is necessary, we will learn from the questions. Okay, thank you so much.